Hello, ladies and gentlemen of Algebra 2. We are kind of changing gears here a little bit, kind of looking at complex numbers. Complex numbers don't get intimidated by them. Complex numbers are just kind of taking everything that can happen one step further with square roots and things like that. So we need to kind of look at how can we do things with imaginary numbers, and how can we solve with complex numbers. So thinking back to product and quotient properties of square roots. So, you know, if I've got two things underneath a square root, I can split those apart. Likewise, if I've got a fraction underneath the square root, I can do this. I can just split it up there. So, you know, if I've got the square root of, 36, well, that's equal to the square root, that's equal to like 9 times 4. Well, that's equal to the square root of 9 times the square root of 4. Likewise, if I've got the square root of, say 4 over 9, that's the same thing as square root of 4 over square root of 9. So those are just kind of some examples of what's going on here. So just kind of remembering a couple things. One, you cannot have radicals in the denominator. And if it's going to be simplified, there can be no perfect square roots underneath underneath the square. So I can't have like, square root of 40, because that can simplify to square root of 4 times square root of 10. So my simplified answer would be 2 square root of 10. So now, a couple things to remember. All these perfect squares up through 16. So what you can just, most everybody knows through 10, just try and memorize the ones up through 16. And those are the ones you need to be, that are going to be expected, that you need to know 1 through 16 just by looking at it. So if I'm simplifying a square root, notice, I'm not saying decimals, okay? No decimals. If you see simplify and you put decimals, you're wrong. So no decimals here. I want to simplify it. That means I got to break it apart into things that are perfect squares. So here I want square root of 25 times square root of 2. And when I do that, square root of 25 is 5. So 5 square root of 2. That is my simplified answer. 45, I want 9 and 5. 9, I take the square root of, it becomes 3. 3 square root of 5 is my answer. Now, here's one mistake a lot of kids make, and I don't get why they do this. So if you have like square root of 9, that answer is going to be 3. For some reason, kids put that my answer is square root of 3. No, you already took the square root once. You don't have to do it again. So don't do it again. So it's just going to be 3. There's my answer. The square root of 9 is going to be 3. So if I'm looking at these, 128, you might have to play around with this a little bit. Not for nothing, I know that that's going to be 64 times 2. Well, the square root of 64 is going to be 8, so it's just going to be 8 square root of 2. Thinking about this a little bit, think about, well, square root and square actually cancel each other out, so my answer there is just going to be x. And kind of one way to think about that is, think about what square root literally does. Okay, think about what this literally says. It literally says, what number times itself gives you that number underneath here? What number multiplied by itself gives you 100? Well, 10. So what number multiplied by itself gives you x squared? Well, squared literally means multiply by yourself. Okay, so if I start throwing in variables here, just not a whole lot changes. So if I can take this kind of piece by piece, and I'll go like square root of 25 by itself, square root of x squared by itself, square root of y to the 4th. So square root of 25 is just 5. Square root of x squared is just x. Y to the 4th, I can split that into square root of y squared, square root of y squared. So that's going to be y times y, and that's going to give me y squared. Now another way to think about it is this. If I've got the square root, and underneath I've got, say I've got like x to the 6th. Square root at this is equivalent to saying x to the 6th raised to the 1/2 power. So square root means raising something to the 1/2 power. So if I've got 1/6 raised to the 1/2 power, power to a power rules say I take 6 times 1/2, which would be x to the third, and that's going to be my answer. So just another way to think about it, if you want, is that it's going to be over. Is that it's going to be raised to the power of 1/2. So if I look at f, x is squared over x. If I simplify that, that's going to be square root of x over 1. So that'll just be square root of x. That's as far as I can go with it. So here I want to split and go square root of 11 over square root of 49. Square root of 11 I can't do much with. On the bottom, that's going to be 7. That's legal. That's fine. Okay, there's no square root in the denominator, and that's what I want. Okay, now it's simplified. So here, before you start getting tricky and start trying to simplify things in here, what I would want to do is go square root of 32 over square root of 81. So square root of 81 is going to be 9. Square root of 32, if you left it like this, this is going to be wrong because it's not fully simplified, okay? You can simplify square root of 32, and you can simplify that into 16 and 2, so that's going to be 4 square root of 2. So my answer here is going to be 4 square root of 2 over 9. That's going to be my answer. This is right. That's going to be fully simplified. Square root of 32 over 9 is not simplified. So if you do that, technically you'd be wrong. Here, for this one, what I might do is I might actually simplify 32 over 8. That simplifies to 4. So I might take square root of 4 times square root of x. So my simplified answer is going to be 2 square root of x. So if I solve, if I'm going to solve for this, I'm going to use the square root property, then my answer is going to be both a plus and minus. So if I have x squared, next step, change that to 25. Square root. X not only equals 5, x also equals negative 5. Okay, because technically negative 5 squared would give me positive 25, and that's what I want. So I want both of those here. So if I go here, add 45, 2x squared. Let's clean it up a little bit. 2x squared equals, let's see, that'll be 98 divided by 2. 49, hopefully you recognize when I square root that. My answer is going to be 7 and negative 7. So taking a look here, trying to put together some things on this problem. So I want to add 12 to both sides. So that means I'm going to have x plus 2 squared equals 25. So if I square root both sides, I have x plus 2 equals 5. I also have x plus 2 equals negative 5. So x will equal 3. X will equal negative 7. There's my answer. All right, so if I take a look at this one, hopefully you might start to see kind of my hiccup here right before as I get going. So if I subtract 48, 3x squared equals negative 48. Divide by 3, x squared equals negative 16. Square root. Some of you guys that are going to get this wrong are going to try to tell me it's 4, or maybe you're clever and you think it's going to be negative 4. Neither of those are true. I can't take the square root of a negative number. All right, it's against, you can't think about what multiplies by itself to get a negative 16. Well, nothing, because even negative 4 squared is positive 16. 4 squared is positive 16. There's no way to get negative 16. Here's where complex numbers come in. Complex numbers say this. I squared is going to be negative 1. Okay, I stands for imaginary. So that means that I is going to be the square root of negative 1. So anytime we can figure that out or we can work that out, all we do is we put in I. So when I look at this, subtract 2, 2x squared equals negative 2, divide by 2, x squared equals negative 1, square root. So x is going to equal I. There's my answer. So if I kind of look at this, so kind of thinking about all the different kinds of numbers that kind of happen here, let's kind of take a look. So real numbers are going to be everything here. All right, rational numbers are going to be here. All right, irrational are going to be down here. All right, what we got next? Integers, whole numbers, natural numbers. So integers, whole numbers, natural numbers. So we'll go integers, whole, natural. Imaginary is going to be over here. And then complex numbers really kind of bridge the gap because there's a real part and an imaginary part to complex numbers. So complex numbers are going to be part of both categories. All right, so it's almost like there's a circle that is included in both. So if I take this, here's kind of all I'm doing. It's a real easy step. It's not too complicated. My first step is just going to be this. All I'm going to do is say, I'm going to split this into square root of 18 times square root of 1. That's all I'm doing. So square root of 1 we call I. Square root of 18 I keep splitting into 9 and 2. So that's going to be 3 square root of 2 times I. Simplified, it's going to be 3I square root of 2. There's my answer. Negative 125 x to the 5th. So again, I'm going to split. I'm going to go 125 x to the 5th times negative 1. 125 is going to be, that's going to be 25 and 5. X to the 5th is going to be, I'm going to go x squared times x, and then I'm going to bring square root of negative 1. So this becomes 5, this becomes x, so that becomes x squared. 5x is left underneath times I. So my fully simplified answer becomes 5I x squared square root of 5x. There's my answer. All right, so now this became x squared because I have x times x. Okay, and I got that from splitting x to the 5th into x squared, and x. And I did that just to show you guys that x shows up twice. So products of radicals still follows the same rule. So I put them together underneath. Negative 10 times negative 15. Well, that becomes a positive 150. Now I can do this. This is way easier. So I can go 25 and 6. So I can go 5 square root of 6. There's my answer. Here, so I'm going to go negative 2 times negative 7 times I. Well, that's positive 14. And then I've got I squared. So that's 14 times negative 1. So that's negative 14. There's my answer. I squared is negative 1. So add, subtract, multiply, same kind of idea. What you do is you put together what's called the real parts, so like the 6 and 1, and then you put together the imaginary parts, the parts with I. So that's going to be 7 minus I. That's my answer. Here, same kind of idea. It almost acts like a variable in this situation. So I go plus 1 minus 2I. So it becomes negative 1 plus 3I. There's my answer. So it's not too tough there. The fun part begins when you have to multiply. So what's kind of fun is that this problem right here is what you call a conjugate because it's got 1 plus 1 minus. So if I just follow my rules, draw my box or whatever, what I can do is just kind of follow along here because watch what happens. 36 plus 6I minus 6I minus I squared. So plus 6I minus 6I cancels out. This 36 minus I squared is negative 1. So 36 minus negative 1 becomes 37. There's my answer. Now, only in conjugates is that going to happen, okay? Down here, these two are not perfect opposites of each other. So when I do this, I'm going to have 6 plus 3i plus 4i plus 2i squared. So that's going to be 6 plus 7i. I squared, remember, is negative 1, so I go plus 2 times negative 1. So that's going to give me a minus 2. So I have 6 plus 7i minus 2. So my simplified answer is going to be 4i, or sorry, back up, 4 plus 7i. There's my answer right there. That's as far as I go. So now take a look. The base of a parallelogram is half its height. The area of the parallelogram is 18 inches squared. What are the lengths in the base? So parallelogram time. The base of a parallelogram is half its height. So if I go h, then this is going to be 1/2 h. But if I flip it around, it becomes a little bit easier to work with. So let's do that. Oh, wait, wrong button. So if I flip it around and I do this, so you know what? If I go b, then the base is half of this, so that's going to be 2 times b. So that's 2 times b equals 18. So 2b squared equals 18. So b squared equals 9. B equals 3. Now, why did I choose 3? Why not negative 3? Well, negative 3 doesn't work. Okay, you're looking for a distance. You can't have something negative 3 long, so it's got to be positive 3. So this is going to be 3, and this is going to be 6. There's my answer. All right, that's all I got. Come talk to me with questions. Play around with this. A lot of pieces, a lot of simple things, but you got to keep them all together. All right.